Okay, this brief demonstration video is meant to show the 3 top-level enterprise value propositions when running Apache Cassandra atop VMware Tanzu. The first value prop is the ease with which you can deploy a multi-tiered Apache Cassandra cluster data platform along with automatically generated and maintained service endpoints for each of REST, GraphQL, and the document API. First, we take a brief look at our Tanzu cluster. We look first at the namespaces, and we look at each of the existing pods. This portion of the demonstration is sped up 8x to save screen time. Here we see the provisioning and launch of the DataStax Kubernetes and Tanzu operator for Apache Cassandra on this top line. This Tanzu custom resource definition object, an operator, calls to create a 2-container, single-node Apache database server instance. We'll use a single-node Apache Cassandra database server instance so we can kill it and watch it recover nearly instantly later in the demonstration. And then we called to create the Tanzu replica set, which hosts the automatically generated and maintained service endpoints for our end-user application. A few minutes of real wall clock time, we display this portion inside of a few seconds. Next, we demonstrate automatic recovery from node failure. First, we execute a hard and immediate kill inside the main pod hosting Apache Cassandra. Here the video is executing in real wall clock time. Even with safeguards in place to prevent accidental node restart, the node is discovered to be ill and recovered in 60 seconds plus or minus. Tens of megabytes of data or terabytes of data, one node or hundreds, it does not matter. Automatically, the pod is recreated using the previously existing physical volume provided by Tanzu. This allows us to not have to stream recovery data from any of the other Cassandra nodes. This new node comes up within seconds. We see that the Tanzu physical volume and physical volume claims predate the now newly created recovered Apache Cassandra node. Lastly, to aid in programmer productivity and to accelerate time to innovation, we display the automatically generated and maintained service endpoints in each of REST, GraphQL, and the document API. This functionality arrives via the open source Stargate.io project, licensed as ASLv2, equal to Apache Cassandra, both of these projects led by DataStax but contributed to by many private corporations and the public at large. Stargate exists as a Tanzu replica set and is a stateless middle tier between the application and Apache database cluster. First, we check to see which tables may already exist in our database using a built-in REST GraphQL schema discovery routine. In each of the next few examples, we supply a token and key value in order that we may authenticate against the Apache Cassandra database server. Using a GET method and a specific URL, we see that there are 2 tables, city and state. Here we demonstrate using GraphQL to overfetch. That is, submitting multiple distinct routines via a single service invocation. These overfetches can be inserts, deletes, updates, whatever. In this case, we choose to query from 2 different tables, where the results from each table can be jagged, meaning returning different attribute names, types, or counts. Here we use the Stargate document API to target the Apache Cassandra database server. The document API gives Apache Cassandra a polymorphic schema capability. That is, columns, column types, and even entirely new tables can be created merely by the act of an insert, update, and so on. A polymorphic schema capability can be a large productivity boost to developers, removing the burden of schema change requests, accelerating time to value, and more. And through an advanced storage design, documents with just a few or hundreds of attributes can be updated and retrieved with just a handful of automatically created and maintained indexes. Here we call to put into a table titled My Collection, which you may recall from our earlier examination of the database with its 2 tables, city and state, does not currently exist. The put calls to insert a document with a good amount of complexity, nested dictionaries, nested arrays, and so on. The result of our put, our call to insert, is an automatically generated document ID. And what good is insert without support for advanced queries? Here we call to select from all documents referencing a deeply nested document attribute. In this case, any document with a car make of type Bentley. No matter how deep or complex our query predicates may be, these queries are supported using just a handful of indexes, not hundreds of indexes as is usually the case with a document database. And then just to be excessively verbose, we rerun our earlier GraphQL schema discovery query, which now displays our newly added table hosting our document list titled My Collection. And that completes our demonstration. Quick and easy creation and maintenance of Apache Cassandra clusters atop Tanzu, automated and in a more productive manner for development teams and with less human-introduced errors. Also, zero downtime and low resource recovery from failed nodes. And lastly, automatically generated and maintained end-user application service endpoints.